All right, so this is going to cover the remaining examples that I left off with from the last video. And so I'm just going to jump right into it. So number 31 has f of x equal to x times parentheses 1 minus 4 over x plus 3. Now, the way I work this out might be a little bit different than how you might work it out. There's multiple ways to approach the problem. For one thing, you could use the product rule because you have x and then times and then another factor that you're multiplying it to. But then you'd have to use the quotient rule on the term inside the parentheses where it's 4 over x plus 3. So to lessen the amount of rules I'm applying, what I'm going to do is distribute x. So then f of x equals x minus 4x over x plus 3. Okay, so this is just a preference thing. When I have minus 4x like this, I'm going to write it as x and then plus and then attach the negative up to the numerator of the fraction. So it's minus 4x up top and then over x plus 3. All right, that's a preference thing. You don't have to do that. But I tend to do that, so I usually attach the minus up to the numerator part of the fraction. All right, so if I were to find its derivative, f prime of x, if I have the derivative of x, the first term is x, so that derivative is 1. And then I have plus, and then I have to take the derivative of the minus 4x plus 3. So I'm just going to write the notation d dx of minus 4x over x plus 3. And then do the work for this off to the side. So concentrating on that, my top function write that better. All right, so the top function is negative 4x. Take the derivative of negative 4x. It's going to be negative 4 times 1, which is negative 4. So t prime is negative 4. The bottom function is x plus 3. Taking the derivative of that, b prime, well, derivative of x is 1. So that's like 1, and then derivative of 3 is 0, since that's a constant. So it's technically 1 plus 0, which we know is, you can just write it as 1. All right, so I have all the components, and now I can find its derivative. So it's the bottom function times the top derivative, so x plus 3. The derivative of the top function is negative 4. Minus the top function's negative 4x. And then divide or times the derivative of the bottom function. And that's 1. All of that's divided by the bottom function squared. So that's x plus 3 squared. So it's a matter of trying to simplify what we have. All right, so if I distribute the negative 4, let's make negative 4x and then minus 12. And then I have a negative times negative 4x times 1. The negative makes, double negative makes positive, so that's plus 4x. And then over x plus 3 squared. And I can cancel out the negative 4x with positive 4x to make negative 12 over x plus 3 squared. All right, that is the derivative of negative 4x over x plus 3. So that is this part. So f prime of x is going to equal 1 plus, and then negative 12 over x plus 3 squared. All right. And I'm okay with this as if you put this as the answer, but the textbook goes further and combines it into one fraction. The textbook goes further and makes it one fraction. So I'll show what the textbook answer is, or how you would get to it. So 1 is the same thing as 1 over 1. I just write it like that to reinforce that there's a 1 for its denominator, and then plus, then I have negative 12 over x plus 3 squared. So I have a x plus 3 squared, and I want to make that as the common denominator. I'm going to leave some space here. All right, so the common denominator is going to be x plus 3 squared. So I multiply 1 over 1 by top and bottom by x plus 3 squared. All right, so then that's going to give me the common denominator, and 1 times x plus 3 squared is just x plus 3 squared. So I'm just going to write it as one fraction now, where I have x plus 3 squared, and then plus negative 12, you can just write that as minus 12. And then over x plus 3 squared. And then the homework will keep the denominator as x plus 3 squared, but they'll try to see if they can simplify the numerator some. So they expand the x plus 3 squared in the top. So expanding this becomes x squared plus 6x plus 9. All right, that's the x plus 3 squared, and then minus 12. And then all over x plus 3 squared. So that way they can combine 9 and minus 12 to make minus 3. So f prime of x is x squared plus 6x minus 3 over x plus 3 squared. And I can't cancel out the x plus 3 squared or an x plus 3 from top and bottom because that's not what the numerator is going to factor, because the factors of negative 3 are just 1 and negative 3. or -1 and +3. None of those will add up to give you 6. So this is the answer that the textbook has. And I'm okay with either one of those two that I have boxed. All right, so for this problem, when I took its derivative, so first thing I did was I distributed x, and then after I did that, I took the derivative, and then derivative of x is 1, and then I focused on taking the derivative of the -4x over x plus 3 piece, and that's what I did over here. And that involved using the quotient rule. And from the quotient rule, after I applied that and simplified, I got it to be -12 over x plus 3 squared, and that's the derivative. So my f prime of x is 1 plus the -12 over x plus 3 squared. And I'm okay with that as the answer. The textbook simplifies it, I guess just makes it become one fraction. And that's what's going on here. It's just the algebra steps to make it become one fraction. And then this is the single fraction, x squared plus 6x minus 3 over x plus 3 squared. All right, so that one's done. There's two more problems I didn't do in the last video that I'm going to do now. And let me zoom out. And the ones I haven't done yet are number 47 and 49. And notice that 47 has this trig function cosecant. I'm going to use one of these trig derivatives. So in particular, since it has cosecant involved, I'm going to use the derivative that corresponds to that, so, which is negative cosecant cotangent. All right, so I'm going to work the problem out and apply that, apply that derivative rule. All right, so I want to apply the power rule for the fourth root of t. And you can write the fourth root of t as t to the 1/4 power. And then I have plus 6 cosecant of t. And so recall that if you have the nth root of a, that's the same thing as a to the 1 divided by n, 1 divided by the index of the radicand. Now, the rules I'm going to apply. So I'm going to apply the power rule. And then I'm going to apply the derivative of cosecant, which is a new rule that we just learned. And that's negative cosecant cotangent is its derivative. All right, so when I take the derivative of g prime of t, using the power rule with t to the 1/4, that becomes 1/4 then t raised to the 1/4 minus 1. And then the derivative of 6 cosecant of t. Well, you factor out the 6 and then focus on the derivative cosecant. So b plus 6, and then the derivative of cosecant is negative cosecant cotangent. All right, so then g prime So 1/4 minus 1, that's t to the negative 3/4. And then minus 6 cosecant t cotangent t. All right, and then because it's a negative exponent, you want to make it positive, so I bring that down to the denominator. So it'll be 1/4t to the positive 3/4. So that way it's in the denominator. And then minus 6 cosecant t cotangent t. And then that's going to be the answer. All right, so I got one more. This next one's number 49. And this is the last problem for the section. All right, there's multiple ways you can go about doing this problem. The way I did it might be different than how you might approach it. You could apply quotient rule. I'm not going to apply the quotient rule. I'm going to try to use some trig rules that we know. The first thing I do is I distribute 3. So that's 3 minus 3 sine x. All of that over 2 cosine x. Then I separate it into 2 fractions where they both have 2 cosine x for the denominator. So it'll be 3/2 cosine x. Then minus 3 sine x over 2 cosine x. And then I apply some trig rules. So secant from trig class, that's 1/cosine. So I could write 3/2 cosine x as 3/2 secant x. And then tangent is sine over cosine. So I could write the second term as minus 3/2 tangent x. And I did all this so I didn't have to use the product rule or quotient rule, because those 2 rules require a good bit of steps. So if I rewrite it like this, it's easier for, in my opinion, it's less steps to find the derivative of this. All right, so I'm going to apply what the derivative of secant is and what the derivative of tangent is. And the derivative of secant, so if I go back up to the top of the page, so the derivative of secant is secant tangent, and then the other one involves a tangent, and derivative of tangent is secant squared. So those are the 2 derivative rules I'm going to apply to this problem. All right, so derivative of secant tangent, derivative of tangent is secant squared. All right, so when I take the derivative of y, y prime, that's going to equal 3/2 times the derivative of secant. Derivative of secant is secant tangent. So this will be secant x tangent x. and then minus 3/2. And then I take the derivative of tangent, and the derivative of tangent is secant squared. All right, and since they have 3/2 for both terms and they have a secant, I would factor out 3/2 secant x. And that's going to give me tangent x minus secant x. All right, and then that's going to be the answer. Okay, so just to recap, so I rewrote the problem, I distributed the 3, and then I changed that into 2 fractions. Just because of adding and subtracting fractions, we can change one fraction into 2 fractions where they both have the same denominator. In this case, it's 2 cosine x. Then I use some trig rules or identities, where secant is 1 over cosine, so that's why I changed 3 over 2 cosine x into 3/2 secant x. And I know sine over cosine is tangent, so I changed the second term into negative 3/2 tangent x. And that was easier, in my opinion, to do it this way, so I can just apply the new derivative rules for secant and tangent. And the last thing I did was, well, they both have 3/2 in the secant x, so I factored that out. And that left me with tangent x minus secant x. All right, so that's where I'll stop it. This is the end of this section. The next section is going to be dealing with the chain rule.